In-memory data stores are the backbone of modern applications. They enable lightning-fast performance. For years, Redis has been the king, but Redis' single-threaded architecture can start to become a bottleneck, especially with today's multi-core processors and demanding workloads. We'll enter Dragonfly DB. This is a new in-memory data store, not a Redis fork by the way, but still designed as a drop-in replacement for Redis, and it promises significantly improved performance through its multi-threaded architecture. So let's compare them. I'll be taking a look at the performance using my own benchmarks, then we'll take a look at the architectural differences, as well as any developer experience ones. Hopefully all of this will help you decide which is the right choice for your needs. Hey, Future James here. In the process of making this video, I actually got the chance to talk to the co-founder of Dragonfly, Roman Gershman, so be sure to subscribe as I'll be releasing that tomorrow. Let's start by talking about Redis. It needs no introduction. It's almost synonymous with in-memory data store at this point. It's been around for 15 years. But it does have a controversial architectural decision that many have questioned if it's still appropriate. As I said, it's single-threaded. This means that a single process serves all of the client requests using a technique called multiplexing. This mechanism allows a process to monitor multiple streams, such as network connections, and handle them efficiently without blocking, using an event loop to manage incoming client requests and execute commands. This single-threaded nature of Redis eliminates the risk of race conditions, ensuring data consistency even with multiple clients accessing it concurrently. But while this single-threaded model does offer many benefits, it also has some downsides. This architecture can lead to underutilized CPU cores, as well as performance bottlenecks when handling complex or long-running commands. This is where Dragonfly DB comes in. As I said, this isn't a Redis fork. Dragonfly is actually built from the ground up to leverage multi-core processors. It aims to provide a seamless transition for Redis users though, literally just swap an endpoint as it should be compatible with the Redis API, all of this while claiming superior performance. Now it does this by employing a multi-threaded shared nothing architecture. Dragonfly divides the entire dataset into shards. Each shard is then assigned to a dedicated thread, enabling the parallel processing of requests. Since a single key in a shard is managed exclusively by one dedicated thread, the shared nothing architecture minimizes the need for complex locking and synchronization mechanisms. Overall, this means increased throughput and reduced latency, especially for demanding workloads. In fact, the headline figure you see on Dragonfly's site is that it says it offers 25 times more throughput on a 64-core, 128GB memory machine. That's nearly 4 million queries per second. But is that claim verifiable? Let's put it to the test. For my benchmarks, I used an 8-core 32GB EC2 instance for both the Dragonfly DB and Redis servers. I then had a separate 16-core 64GB machine to run memtier benchmark. This is a load testing tool by Redis. All instances were within the same availability zone, using private IPs for optimal networking performance. Running memtier then with 24 threads and 12 clients each, performing 500,000 operations, here's what I saw. In write operations, Dragonfly DB achieves 900,000 operations per second compared to Redis's 153,000. That is 5.9 times faster with significantly lower latency. Read performance shows a similar pattern, with Dragonfly DB processing 909,000 operations a second versus Redis's 160,000. That is 5.7 times faster, again maintaining a lower latency. Even with pipelining, where both databases show improved performance, Dragonfly DB maintains its lead with 2.6 million operations a second compared to Redis's 684,000. That is 3.9 times faster, and again, guess what? Maintaining better latency. These results seem to confirm that Dragonfly offers significantly more performance over Redis. Now, we didn't see the full 25 times performance difference from that website, but this is due to me using an 8-core machine instead of a 64-core setup in Dragonfly's original benchmarks. Dragonfly's multi-threaded architecture really benefits from significantly more cores, aka vertical scaling. So it's a complete and total win for Dragonfly, right? Well, I'm sure one or two Redis experts will be commenting that this is unfair and I need to talk about clustering. A Redis cluster enables horizontal scaling by distributing data and workloads across multiple Redis instances. In fact, Redis themselves have an article calling out these benchmarks, stating that this comparison does not represent how Redis is run in the real world. I do find that interesting though, as in this same article, they also say that this is just how many of the Redis providers have chosen to run their services, which almost seems to contradict that point. Anyways, let's add in a cluster. To do this, I'll need 8 Redis instances running in cluster mode. So I'll create 8 directories with a separate Redis config in each one. Then I'll create the cluster by running the Redis CLI with a command like this. Now I did run into an issue here, which I solved by setting a cluster announce IP as well in each of the 8 Redis configs. Before we get into the benchmarks, I want you to keep in mind that to run Dragonfly, I executed a single command. I could have even used a single Docker container. To me, it seems like the Redis argument is that to achieve the same performance, you need to go through a lot of extra effort requiring constant management. Let me know what you think. On to the benchmarks though. For write operations, they achieve nearly identical throughput, though Dragonfly maintains a lower latency. Read operations show a similar pattern, with Redis Cluster slightly ahead in throughput, but again with a higher latency. The most significant difference appears in pipeline reads, where Redis Cluster does outperform Dragonfly in throughput by about 1.5 times, but at the cost of a much higher latency. Now, besides my latency results there, the rest seems to line up with what the Redis team saw in that article. So yes, on these benchmarks, a Redis cluster did achieve similar or better performance in some areas, but as I mentioned, this is a lot of extra effort and overhead. Plus, Redis clusters have some limitations. They require some limitations on key distribution, and sometimes inefficient memory management can lead to out-of-memory issues. All of this can become a burden for you and your team to manage. Dragonfly handles this effort for you right out of the box. Now, my focus here was on that multi-threading advantage, but besides multi-threading, Dragonfly claims even more benefits like faster snapshotting and better memory usage. My final note on performance though is that each company can go back and forth for years attempting to out-benchmark each other. Sometimes what's being tested might not even apply to you. The way to find out what's best is to test it for yourself. Since Dragonfly is a drop-in replacement, this should be as easy as an endpoint switch. The final thing I have to mention when we talk about Redis is the license. You probably saw the controversy when they switched over to their new dual approach in 2024. Essentially, you're good to use it unless you want to compete with them for a managed Redis service. Well, Dragonfly's is similar, but with one key change. Dragonfly operates a BSL license. You can use it, modify it freely, as long as you don't offer Dragonfly as a managed service. But after 4 years, the license converts to a more permissive Apache license, but to be clear, it's for that specific version. Essentially, this allows Dragonfly Cloud to stay 4 years ahead of the competition. There we go, I'll leave all of the resources and benchmark information in the description. Let me know what you think. Have you heard of Dragonfly, or are you going to try it out now? As I said at the start, I had a talk with the co-founder of Dragonfly, which will be uploaded tomorrow, so be sure to subscribe, and as always, see you in the next one.